Our new goal is to use this initial rotation of I to determine the value of I raised to any exponent. The first thing that we're going to do is take a look at the next number after 4 for an exponent, which would be 5. So we'll take a look at I to the 5th power. And I to the 5th power is just I to the 4th power times another I. And we found out that I to the 4th power is just 1. So now we have 1 times I, which is equal to I. But we've also figured out something super important, that if we take out all of the I to the 4th powers from all of these other exponents, that we'll be left with whatever's left over, which will just be a number 1, 2, 3, or 4 that'll match our rotation that we just generated above. Let's take a look at how we can do that. Let's say crazy Mr. Sats gives us a problem I to the 10th power. That's not as easy to write out as I to the 4ths as it was to do I to the 5th power, adding another I to it. So what we're going to do when the numbers get a little bit higher like this one is we're just going to take the new exponent, the 10. We're going to put it in our calculator or do it by hand and divide it by 4. Once we divide by 4, we see that we get an answer of 2.5. And what that means is that it's going around our initial rotation 2 full times, but then going 0.5 more. Well, 0.5 is a remainder of 2, kind of like how 0.25 would be a remainder of 1, and 0.75 would be a remainder of 3. So what this is telling us is that because we have a remainder of 2, I to the 10th power is the same as I squared, or I to the 2nd power, which means that it's just negative 1. All we had to do is use our initial rotation from above. Let's take a look at another example. The next example that we'll take a look at is I to the 23rd power. We're going to take that 23 and do exactly like we did before. 23 divided by 4. And if you're wondering if we always divide by 4, yes, we always divide by 4 because our rotation has 4 pieces to it and then it rotates around again. So when I divide that by 4, I get 0.75. Again, it goes around 5 full times. We don't care about that. We care about the 0.75, which is a remainder of 3, which means that this is the same as I to the 3rd power, which from our initial rotation is just negative I. One more example. The last example that I'm going to do is I to the 9,552nd power, because that looks like something that Mr. Sats might give us because he might think that that kind of thing is fun. But it doesn't matter. We're just going to take that number, doesn't matter what the number is, and we're going to divide it by 4. Always divide by 4. Not in life, but for these problems. We divide by 4 and we find out that there is no remainder, no decimal. That number, 9,552, is perfectly divisible by 4. That means that this is the same as I to the 4th power, one of them, because it just keeps going around. And now we know that that is just equal to 1. So, just to go over everything, if you get a remainder of 1, it's I to the 1st power. If you get a remainder of 2, it's I to the 2nd power. If you get a remainder of 3, it's I to the 3rd power. And if you get no remainder at all, it's I to the 4th power, or 1. Hope this helps.